Show by the principle of mathematical induction that for all n belonging to the set of natural number, the following equation is true. Okay, let us begin. Now, the first task will be to name this particular mathematical statement. So we're going to represent it by P of n. So let's say, let P of n be the statement P of n such that we have 1 squared added to 2 squared added to 3 squared added to all the way up to n squared. This is given by 1 over 6 multiplied to n times n plus 1 multiplied to 2n plus 1. So we are considering this to be the mathematical statement. Now we need to show that this statement is true for all values of n belonging to the set of natural number. Meaning, if we consider any natural number, this statement must be true. So we will verify that this is true for n equals to 1. So when we check for n equals to 1, then our statement becomes P of 1. All we have to do is replace n with 1, but n here simply states the number of terms here. So that are a total of n number of terms. So if we replace n with 1, we don't have to worry about 1 square, 2 square, 3 square. There's some, because that's only a single term, which is the first term here. So that becomes 1 square. So we'll take 1 square and we say that this is equals to 1 over 6 multiplied to, we're going to replace the n on the right hand side with 1. So 1 over 6 multiplied to 1 multiplied to n plus 1. So that's going to be 1 plus 1, simply giving us 2. Multiplied to 2 times 1, so that's 2. 2 added to 1, so that's going to be 3. So on the left hand side we have 1. This will be equals to 2 times 3, that's 6. And we have a division by 6, so that also gives us 1. We know that 1 equals to 1 is a true statement, which means that P of n, this simply implies that P of n, this mathematical statement is true for n equals to 1. So if we consider the first natural number n equals to 1, then the given mathematical statement is true. Now we will be making an assumption here. Now we will suppose that let P of m be also true. So P of m be also true. This simply means that we are considering n replaced by m such that we have 1 squared plus 2 squared plus 3 squared going all the way up to the last term n squared, but we have to replace that n value with m. We have m squared, so this is given by 1 over 6 multiplied to m times m plus 1 multiplied to 2m plus 1. So we're saying that this particular statement is true. And if this is true, then we need to show that P of m plus 1 is also a true statement. If we can show that the next term consecutive to m, so after m comes m plus 1, if we can show that it is true for m plus 1, then we can show that the original statement P of n is always true for any natural number that we pick up. Now, how do we show that P of m plus 1 is also true? Now, what is P of m plus 1? Now, we have to express P of m plus 1. So, P of m plus 1, this is simply going to be 1 squared plus 2 squared plus 3 squared going all the way up to m squared. But since we're considering m plus 1, we have to consider the term that is next to m squared. So that will be simply m plus 1 whole squared. And this should be equals to, what we'll do, we'll take 1 over 6. Now we'll replace this m with m plus 1. So we have 1 over 6 times m plus 1 multiplied to, now m plus 1 added to 1, that gives us m plus 2. Multiplied to, so we have 2 times m plus 1 added to 1, so 2 times m plus 1 is simply 2m plus 2, but we have to add 1 to it. That's going to give us 2m plus 3. So we need to show that this is also true. How do we show that this is true? So we'll start from the left hand side. Now on the left hand side of Pm plus 1, we have 1 squared plus 2 squared plus 3 squared going all the way up to m squared and m plus 1 whole squared. Now, if we consider the first m number of terms, we have already shown that this is a true statement. That means we can replace 1 squared plus 2 squared plus 3 squared all the way up to m squared with this expression such that we have 1 over 6 multiplied to m times m plus 1 multiplied to 2m plus 1 added to the term m plus 1 whole squared. Now we have to combine it, and once we combine it, we should get something of this particular form. That means we should get the right hand side. So what we will do here, we are going to take, since we need a factor 1 over 6, let's take 1 over 6 as the common factor. Now if we take 1 over 6 as the common factor, now what we have here is m multiplied to m plus 1 multiplied to 2m plus 1 added to 6 times m plus 1 whole squared. Now as you can see here, we have a expression m plus 1 here. Now what we can do, we can pull out m plus 1 from both of these two terms such that we have 1 over 6 times m plus 1. This will get multiplied to m times 2m plus 1. We have m times 2m plus 1 added to 6 times m plus 1. Fine. Let's further simplify. Now we'll be having 1 over 6 multiplied to m plus 1. This will get multiplied to, so m times 2m plus 1, so that's 2m squared plus m added to, so 6 times m plus 1, so that's 6m plus 6. Okay, so this is going to be equals to 1 over 6 multiplied to m plus 1 multiplied to 2m squared plus 7m plus 6. Okay, so we have 1 over 6 multiplied to m plus 1 multiplied to, now 2m squared plus 7m plus 6, we can factorize it. So we have 2 times m squared plus 7m plus 6. What we can do here is split the middle terms. Now we know that the coefficient of m squared, that's 2, and the constant term, that's 6. So 2 times 6, so 2 times 6, that gives us 12. Now we're going to take the factors of 12 in such a way such that when we manipulate them, that means we get the middle term, which is 7m. Now we know that 4 times 3, that's also equals to 12. Now we are taking 4 times 3 because we can now split 7m as 4m plus 3m. So this is going to help us factorize it. So from the first two terms, if we take 2 times m as the common factor, so we are left with m plus 2. Then we have 3m plus 6. So from both of them, if we take 3 as the common factor, so 3 gets multiplied to m plus 2. So now we have 2m plus 3 multiplied to m plus 2. So we can now replace 2m squared plus 3m plus 6 with m plus 2 multiplied to 2m plus 3, and this is exactly the expression on the right hand side. Let's verify it. So we needed 1 over 6 times m plus 1 plus m plus 2 multiplied to 2m plus 3. Now since we can say here, so here we have obtained that left hand side equals to right hand side. Now whenever left hand side equals to right hand side, this simply is telling us that p of m plus 1 is true. So p of m plus 1 is also true, and if this is true, that means that the original statement p of n such that 1 squared plus 2 squared going all the way up to n squared equals to the expression 1 over 6 times n plus 1 multiplied to 2n plus 1 is true. This is true for all values of n that we consider that belongs to the set of natural number. So this is principle of mathematical induction, with the help of which we have showed that the statement p of n is true for all values of n belonging to the set of natural numbers.